In order to properly assess the quantitative risks using the net benefits developed in Step 2, you need to make one additional calculation under the no further environmental investigation/build scenario. Factsheet 4, Decision Tree, presents the use of a decision tree for assembling and viewing the information developed by the conceptual site model, the cost estimate, and the cost-benefit analysis. A key feature of the decision tree is using risk analysis to assign probabilities to various decision points that are subject to significant unknown information. The no further environmental investigation/build scenario indicates that no significant environmental risk has been identified by the conceptual site model, and therefore the need to conduct additional investigation into environmental concerns is eliminated. The build qualification indicates that along with this no further environmental investigation decision, the decision is made to go forward with design and construction of the GSI project without gathering further environmental information. However, there is some probability that unknown environmental contamination may exist and will have to be remediated when encountered. To correctly calculate the estimated payoff for the no further environmental investigation/build scenario, the expected value of the net benefit of two possible outcomes, if the site turns out to be clean or if the site turns out to be contaminated, must be calculated. See Factsheet 4, Attachment 1, Risk-Benefit Analysis Tree. The calculation is the sum of the contamination probability for both potential outcomes, clean or contaminated, multiplied by the value of the net benefit for each potential outcome. The contamination probability number can be estimated as different situations determine 40%, 50%, 60%, and so on. In this particular example, the probability for contamination is estimated to be 50%. So, if the expected value of the no further environmental investigation/build scenario is $74,255 if the site is clean, and the expected value of the remediation scenario is minus $281,050 if the site is contaminated, the adjusted net benefit value for the scenario would be calculated as follows. 0.5 times $74,255 plus 0.5 times negative $281,050 equals a negative $103,388. The negative $103,388 represents the possible clean or contaminated outcome adjusted net value of the no further environmental investigation/build scenario. If the contamination probability of the example is increased to 60%, the equation would look like this. 0.4 times $74,255 plus 0.6 times negative $281,050, which equals a negative $103,388. The total probability of contamination multiplier must always add up to 1. You would place the net benefits, including the adjusted value for the no further environmental investigation/build scenario, in a comparison table similar to the one contained in Factsheet 4. The risk-benefit analysis tree illustrates the decision-making process used to compare the net benefits of each scenario. Using the example net benefit values on Factsheet 4, the alternative with the highest net benefit value is the mitigation scenario. Although the net benefit of the no further environmental investigation/build scenario is higher when observing the cost-benefit analysis prior to application of the risk analysis, factoring the risk of encountering unknown contamination results in negative net benefits when the expected value is calculated. The mitigation scenario, because it is designed with the assumption of contamination, has no appreciable risk of failure. It should be noted that this example is a very simplified and high-level use of risk analysis. The application of risk and probability and various alternatives may be added at additional levels to develop a more detailed and comprehensive analysis. Thanks for watching, and I'll see you in the next video where I discuss what to do when you approach contamination. This video is brought to you by the New Jersey Institute of Technology's Technical Assistance to Brownfield Communities program, otherwise known as NJIT TAB. Visit www.njit.edu/tab for more information.